All right, guys, welcome to the second part of Unit 3, Virtual Networking. And I talked about it before. I just covered virtual networking in general. Here's what we're going to get into in here. And I apologize if I lose you guys in some of this. Even it goes over my head sometimes too. So you hear me talk about virtual routers and virtual switches a bit in terms of what they just replicate physical hardware. I will go more into detail what they are, which pictures. I guarantee there's pictures. We can see it, okay? So we're going to go over switches, routers, all virtual stuff, virtual LANs. I've mentioned a couple more virtual LANs and what's called trunking. Just one point to another is trunking. That's really easy. Connecting two virtual LANs together, or one link is called trunking or truncating. Network isolation and segmentation. Why would you want to have networks that are isolated? Why would you want to have your network broken up? For example, you can see if I got my phone out. A second, turn on my Wi-Fi. Just so I can show you a bunch of different wireless networks here at work. It's hard to see. Where's the show? Damn it. Well, I'll show you there's an org, which is for workers, a guest account for guests, one for students, and one that's called instruction for instructional devices. So it's 4 network segmentations there. And they're separate for a reason, right? So have things separate. One's for workers, one's for instructional staff, also for workers, just classroom computers, classroom laptops. One's for the students to use where they have very limited bandwidth, so it's really slow. One for guests, it's even slower than student. It's the slowest network we have. It's under 5 megabytes. It's slow for doing anything. You can't even watch a movie on it, I think. But that falls under like segmentation. Anyhow, software-defined networking, SDN. So there's only 23 slides, guys. Let's get into it. And again, I hope you're enjoying your Thanksgiving. Hopefully you're watching this before Thanksgiving and you did your homework before Thanksgiving so you can enjoy your Thanksgiving break. Now, have a fun weekend, a fun 4-day weekend. If you're watching this right now and it's Black Friday, I hope you were able to shop and buy some stuff that you were looking for that's on sale. I really hope you didn't have to brave the mobs like I did back in the early 2000s when I worked retail, when I worked overnight. I'm not going to get into it, but it sucked, especially when you can't enjoy Thanksgiving with your family. So, into the lesson now. I ramble. I do apologize. I'm just trying to keep it interesting. Hopefully your eyes don't get glazed over with this stuff. Virtual switches and router. What is a virtual switch? A virtual switch is completely virtual and connect to a network interface card. Oh, I'll be damned. Look at that. That's what it's showing. A virtual switch connecting to a network card right there. That's what that green thing is. What is the function of a virtual switch? The function of a virtual switch is to connect different segments of a network. It's quite similar to that of an Ethernet switch network hub. I think I have one here. Give me a second. I saw one back here. Ah, damn it. Get out from my damn office chair. Nope. Got snacks though. Snacks always work. Nope, no virtual switch here. No physical switch I can show you. Sorry, guys. I have one in my main office, which is not this office I'm in right now because I'm not on my main campus. I'm on a satellite campus. Still, until after Thanksgiving when I am recording this. So, right? So it connects things like a regular switch to a network. A virtual switch differs from a hub in that it does not broadcast data packets across all ports. Instead, it filters and forwards selective data traffic based on the media access controller MAC addresses, which we explained. Let's find out what the MAC of this computer is because I'm just curious. And I'm not trying to waste time. I'm just trying to find out what it looks like. If I type in ipconfig, expand your okay, yes, sir. There it is. Ta-da! Here's my physical address on this. That's my MAC controller right there. Ta-da! 40 Bravo 0 34 1 Alpha 62 98. 9 Bravo, not 98. Okay. So decreasing the overall network response time. So just forward stuff. More into it. A virtual switch is meant to provide a mechanism to reduce the complexity of network configurations. Okay. This is achieved by reducing the number of switches that need to be managed after taking the network size, data packets, and architecture into account. So how many virtual switches are you going to need for like one virtual network? It's the question. 1, 2, how many things are you hooking up, etc. How many things are you virtualizing that? But here's the thing about virtual switches. Remember you probably heard me call a switch a dumb switch. A virtual switch is intelligent. The hell, it's smart. You can also ensure the integrity of the virtual machine's profile, which include network and security settings. So you can program these things, believe it or not. Here are some advantages of these things, of these virtual switches. Helps in easy deployment and migration of virtual servers. Cool, because you can learn, right? Allows network administrators to manage virtual switch deployed through a hypervisor, Hyper-V. or whatever you're going to be using or work on, or want to learn about, go for it. Compared to a physical switch, it is easy to roll out new functionality, which can be hardware or firmware related. It's virtually just tell it to do this and it does it. Okay, cool. So let's get into the virtual router. Well, what is a virtual router? A vRouter is a software-based router that can be deployed as either a bare metal image (BMI) or a virtual machine (VM), which is then installed on top of turnkey vendors, third-party CTIS, or do-it-yourself hardware, or in cloud. COTS. I'll have to look that up later. Actually, no, I'm not gonna look anything up. I will make it 5 extra credit points. Look up what COTS is and give me your interpretation of it, not the Google definition you find. Tell me what it does in your own words. Send it to me before the following Sunday of this, before Unit 4 goes live. Send it to me as a PM on Canvas, not Discord, or email it. The reason being, I can't accept grades stuff to Discord. I can't talk about grades in Discord, but I can talk about what we're doing. So that's why that's there, and so you can get a hold of me. Anywho, how does a virtual router work? In practice, virtual routers perform the exact same work of hardware-based Layer 3 Internet Protocol routers, so they just function like a router, essentially using protocols to move data between computer networks along the shortest possible or mostly desired policy path. So how many hops is it? 1, 2, 3, 4, 5, 6. What's more efficient? 6 hops or 3 hops? 3 hops. So use a 3-hop path. Common vRouters use cases including edge networking, cloud connectivity, and VPNs. So, virtual router advantages. Virtual routers go into sleep when we're not in use, so they go to sleep, which is cool. It saves you power. The first major benefit is that they consume less power than traditional hardware-based routers, which are on all the time, because the software goes into sleep whenever it isn't in use. Straightforward. This means you can have more devices on your network without having to worry about memory overloads and other technical issues with networking equipment. Here's the thing about that, and it's true. Back when I worked at Tustin, this is like 10 plus years ago. This is in relation to this. We had a big physical router in downtown. We called our district office downtown because it was downtown in the city. And one time we just started noticing our network get really slow or would crap out. What the hell's going on? Our big router we had was just honestly melting. And I mean, it was not on fire, but in the sense of it was getting really hot. It would crash and turn off. Like every computer, every desktop, laptop that you own, if it gets to a point where it gets too hot, it shuts down and saves itself. It was overheating because there was too many devices being routed. Go figure. So if that was a virtual router, it wouldn't have that problem. It would just go to sleep when it wasn't being used. It wouldn't overheat because it's not a real thing in the sense of, a real router. It would just go to sleep and not worry about it if it wasn't being used and save power and save energy and be more efficient. So virtual routers are easy to set up and configure. Virtual routers also allow for easy setup and configuration as there's no hardware required for setting the system up. It's all software and you're done. This makes virtual routers an ideal option for small businesses or organizations who need something done quickly but don't want to spend money on laying down complex routing systems within the office at the moment. So if it's a small like mom and pop equipment business or a small like little company, they're more likely to have virtual routers than a physical router, depending on what they need it for. Virtual. I'm rolling my freaking R's now. Virtual Subaru whale. Sorry. Virtual routers are inexpensive and save up costs. One great benefit of setting up a virtual router is how inexpensive these networks are when compared with buying an entirely new set of physical gear. Look up how much a physical router is, like a business one. They're not cheap. So if you're looking for ways to save costs and your precious time while maintaining your security, setting up a virtual router is the best option. Pretty cool. So what are some disadvantages of a virtual router? That's what's next. I try to show you what's good and what's bad about it. That's why I have these kinds of slides in there. Hopefully you're taking away something from like, oh, interesting, cool. Or, guy's full of hot air. He's not doing his job. That's up to you to decide, not me. Virtual router disadvantages: limited bandwidth. Virtual routers do not offer unlimited bandwidth, which means that they can only support up to so many devices on the network at one time. Organizations may want more than just a couple dozen computers hooked up into their system and will need to consider installing physical hardware-based routing equipment instead of relying solely on software solutions. In other words, they have a limit to everything, guys. You can't do more than probably, I would say, 6 machines at most off of a virtual router. So, compared to 12 machines, that's kind of, or networking 12 machines, that's kind of like, not that good. Virtual routers may have limited routing options. One other downside is that while some virtual router packages may be able to provide for easy setup configuration, others might have limited routing options. This means you won't be able to use them in environments where complex networking needs exist, such as those found within hospitals, universities. These types of organizations should use hardware-based routing equipment instead. Most hospitals have physical routers and they use virtual routers. It's true because it's just the need's too big. Because the thing about it, I'm just talking about hospitals, not schools or anything. They do have computers and laptops. What about tablets to use for intake? What about, what they use smart TVs now? What they use small little portable stations or towers that are like this big or on the back of a monitor that are like the equivalent of a full-size tower. They work in terms of performance, all those kinds of things. IoT, Internet of Things. Well, if they have a smart fridge, you never know. Things like that. You got to take all that into account. Virtual routers cannot be used for wireless access points. One major drawback is that virtual router cannot be used as a wireless access point, which means you need to purchase a separate device if you want the ability to send out Wi-Fi signal from your network. Yeah, you can't use a virtual device for that. So kind of makes sense. This will also make it so all of your devices are connected together with one another in order to maintain security and privacy online. So pretty straightforward there. Let's get into VLANs and trunking, or truncating, as some people like to call it. Oh boy. VLANs, a virtual LAN. Wow, that's what the V stands for, virtual. What does LAN stand for? Local area network. A logical overlay network that groups together a subset of devices that share a physical LAN, local area network, isolating the traffic for each group. VLANs provide segmentation based on broadcast domains. Well, what the hell does that mean? So depending on the area it's broadcasting in terms of its domain, that's what it segments. VLANs logically segment switch networks based on the functions, project teams, or applications of the organization's readiness, regardless of physical location or connections to the network. So let's say I'm in a 3-story building and the whole bottom floor is HR, or 6-story, just for the sake of argument. Then I have finance split between the 2nd floor and the 3rd floor. Their network would just be the same network that they use for the finance network. They're connected all in one network. Anyone that's in finance, even though 3rd floor or 2nd floor, they're all connected together. I'm using my hands because I don't have a diagram. But HR, if it's on its own network, it's on the bottom floor, and that's their network. That's what that's referring to. It could be separate, like, even HR could be like a 4th floor. They'd be on the same network that HR is on from 1st floor because it's HR. Communicating among VLANs will still require a router, but only one physical connection will handle all routing. Moving on. So what do VLANs address? And I'm not talking like MAC address. I'm just thinking, what did they, figure out for you? What can they do? Scalability, security, network management, broadcast filtering, traffic flow management. Switches may not forward any traffic between VLANs, as this would violate the integrity of VLAN broadcast domain. There's a way to make it do that, though. Traffic must be routed between VLANs. I forget what the name of it. That's why trunking comes into play. Duh. Sorry, I forgot for a second. Again. Excuse me, guys. Oh Lord, I am getting tired and hungry. Truncating can get really, really jumpy. So we'll get into that after this probably. But we're talking about how to configure a VLAN here. So that's how VLAN works. There's a picture of it. It's pretty straightforward. The configuration of VLANs or virtual LANs involves similar processes as physical network configuration. Good to know. You need to discover the network nodes you need to manage. This next step is to establish VLAN configuration files to keep track of dedicated nodes. Once configuration is complete, you can archive them or edit them for troubleshooting diagnostics. One of the simplest ways to set up a VLAN configuration is to use VLAN configuration tools. Tools, that's what they're for, to exchange information and automate configuration files for updates. Pretty straightforward. Why is VLAN management important? Manual VLAN management can be challenging, especially when you have a large network with multiple VLANs. So imagine you have a network of like 500 people, and you have like 60 VLANs within that network. So that's 160 networks in total. Or not 160 networks. That's like 60 networks plus your physical network. 61 networks to manage, and it just looks like one big network. Looks like spaghetti. That is hard. Manual execution and configuration changes can increase the risk of inaccuracies and errors that can lead to downtime and latency issues. It can also bring about unnecessary or unproductive conflicts for your security compliance reporting. That's something you get into later. But for example, excuse me, if one of those 60 virtual LANs breaks down or whatever, how can you troubleshoot something that isn't real? You have to go look at configuration files. You have to go look at last good known good configurations for the network, what broke, what changed. It's pretty hard to do that, even with tools. So you got to get really good at it. So that's what you got to learn how to segment right. From this range to this range is this network. From 10.0.0.2, because the one's 0 for the gateway, from 2 to 24. That's for HR. From 26, because you're saving 25 for another gateway for some weird reason, for just like financing. From 26 to 40, that's finance. So if there's a problem with the network anywhere in there, they'll tell you. HR says they can't connect, so you gotta find out why. This is the range from 2 to 20, what I just said, or 25 is what I said, whatever I just said, I can't recall. Gotta figure out what broke between here and there. The best way is to keep an accurate and up-to-date configuration set up to maintain security, compliance regulations, and catch potential issues in your virtual network. VLAN management software helps you gain real-time network updates, receive instant alerts about modifications, and network nodes. These tools can also help in disaster recovery management, which I'll get into much later. So let's talk about some advantages of VLANs here. 1 second, guys, I need some water. What are some advantages of VLANs? It saves costs. Workstation for devices associated with a particular VLAN can communicate via switch, eliminating the need to use routers required to receive and send data on a computer network from outside the virtual LAN. Pretty cool. Routers can cause bottlenecks, though, and raise security concerns due to external data exchange in massive amounts. Kinda. On the other hand, switches have fewer capabilities than a router. Remember, they can be dumb if they're not virtual ones, but they can exchange information with the devices with the network and manage the data load efficiently. This setup configuration can help you organization, cut down the cost of investing in routers and decreasing overall network latency, network lag in time up and time down. Offer greater flexibility. Virtual LANs are more flexible than physical networks. They can be easily configured, updated, and assigned based on port, subnet, circuit, and protocol criteria. Sorry. As these networks are independent of proximity to other devices or physical connections such as wires and cables, it becomes easier for you to collaborate with your team and exchange data. Simplify administration and enhance security. Virtual LANs don't require in-depth administrative monitoring. These networks allow you to limit, change, delete, update, or modify access controls and permission rights. If you need to provide access to specific groups of users, you can divide systems and devices into multiple LAN segments to ensure security. There's no need to reconfigure virtual LANs if the devices, systems, or user groups associated with the specified network are shifted. That way, your organization can save time, cost, and resources. I don't have really major disadvantages for VLANs, guys. I didn't make a slide for it because the major thing is it can just break. And like I said, how would you troubleshoot something that isn't real? You have to look at config files, you have to use your software. That's essentially it. VLANs aren't that crazy, but that's all there really is for downsides, but it's not that big of a deal in terms of versus the advantages, because that's what you expect to happen when things break, right? How do you fix it? So, ta-da, the GIF I talked about. VLAN trunking. Remember I talked about connecting two VLANs, it goes against natural order or whatever prior? That's what this is talking about. You're creating a pathway between two virtual networks, between the routers, though, not at the virtual network layer, which is VLAN 20 out there, VLAN 10 up there. VLAN trunking allows switches to forward frames from different VLANs over a single link called a trunk. This is done by adding an additional header, which you can see there in the image, called the Ethernet frame, ETH. The process of adding the smaller header is called VLAN tagging. So moving on, this is going to be used for a bit, so you'll see the motion. If for some reason you guys get too dizzy with it, you can pause it. There should be a pause button in there, which I can't do in the presentation mode, but you can pause the animation. Why is trunking important to VLAN configuration? With VLAN trunking, it's possible to extend the VLAN across the network. While you implement multiple VLANs across the network, trunk links are necessary to ensure that VLAN signals remain properly segregated from each other, to reach their intended destination. So this is also more efficient as multiple VLANs can be configured on a single port. So you can have multiple virtual networks running off one port. With these multiple VLANs on a single port, the system has to have a way of distinguishing and routing signals. A trunking VLAN port always uses identifying tags to mark frames as they pass between switch tags to mark frames as they pass between switches. So anything with destination 20 gets tagged. Anything with destination 10 gets tagged. If we had a VLAN 30 and it's going to VLAN 20, it's tagged. That's what it's referred to. Again, it's still here. So what's the main advantages of VLAN trunking or truncating? I might space that, but it doesn't look bad. VLAN trunking filters out the noise. that's what's in quotes, of overlapping data during transmission, freeing up more bandwidth so that data can be sent more efficiently. The whole point is to be efficient. That's what it means by filter. And what it means by noise, if it's setting things to 10 and something for 20 comes in, it puts the thing, whatever, it's 20 in a pause moment. So it sends whatever's 10 first because it comes first, then 20. That's what it's talking about. I know it's a little weird, but that's how it works. It's pretty simple. Just implementation of this stuff is very hard because networking is a beast. I'm not kidding. By consolidating multiple VLAN devices and removing the overlap between those that do not need to communicate, VLAN trunking makes for a cleaner network design. That's why there's only one trunk. Imagine there's like 15 different trunks. I don't mean trunks for Dragon Ball Z. Don't think that. Just it's called trunking. So let's talk about isolation and segmentation. What is network isolation? That's what that is over here on the left. That's what the image shows. Network isolation refers to the practice of restricting communication between different parts of a computer network. Okay. The goal is to enhance security by preventing unauthorized access and limiting potential impact of security breaches. Cool. In simpler terms, it is like creating virtual fences. So it's making fences around stuff. Pretty straightforward within a network to keep different segments or devices separated. So here are some examples of isolation. A shared network. Without isolation, all departments are on the same network and any device can potentially communicate with any other device. So it's like having one big network for your work area. So let's say you work at, I don't know, tired of using institutions and hospitals. It's like having imagine the Air Force had one big network for everything. The Air Force could see everything that was in development for R&D and everything that are in their financial budgeting area, all just one big thing. Yeah. Now, isolated networks with network isolation, you can set up separate networks for each department. You can talk about like HRs with HR, financials with finance, or accountings with accounting, and then graphic design will be with graphic design, things like that. Devices in the finance department can communicate with each other, but prevent different communication with devices in the marketing or research departments. Ta-da! I keep mentioning randomly, but not marketing or research, which I just did prior, but that's the whole point. Sorry, guys. It's a really simple example, and it's a good example of why you would isolate and who would talk with who. That's what it means. Firewalls and access controls, which we talked about prior. You use firewalls and access control to enforce these restrictions. For example, sorry, guys, I don't mean to be rolling my L's and R's today. I'm not having a good evening. I don't know what's up with me. For example, I think I'm reading too fast. Sorry, guys. For example, a firewall, we're almost done. 6 more slides. For example, a firewall can be configured to allow communication between devices in the finance department while blocking attempts for devices in other departments. Finance, guys, it's about money. Money kind of gets people's attention. That's just the way I look at it. This isolation, so enhanced security. This isolation enhances security. Even if a device is one department is compromised, the impact is limited because the attacker is isolated from other parts of the network. So let's say somebody, Bob, I use Bob a lot. Hopefully I don't have anyone named Bob in this class. If I do, I apologize. I'm not picking on you. Just a random name. Or John Doe. There. I have nobody named John Doe I can think of in this class. So let's say some John Doe from marketing. Ooh, I didn't pick something I normally use, right? Clicks on something by accident and just installs some software, that's spy software or virus, and it's just like, oh crap. Only his machine's compromised, right? Well, you can shut the port down to his network so that machine doesn't communicate with anything. And there. If anything gets spread from there, it's only in marketing. You won't leak out or mess anything else up. I could use a more choice word, but I prefer not to. Moving on, guys. Let's talk about the benefits of network segmentation. Enhanced security. By isolating network segments, the impact of security breach or authorized access is limited to specific segments, preventing lateral movement and reducing the potential for widespread compromise, which I just mentioned prior, which is true. Access control. Network segmentation allows organizations to apply granular access controls based on user roles. So administrators, accountants, HR, secretaries, things like that. Device type, iPads, iPhones, cell phones, all their own groups, or security requirements. Who needs access to what is the way I look at it. This helps enforce the principle of least privilege and restricting unauthorized access to critical resources. Makes sense. Compliance and regulatory requirements. Many compliance frameworks and regulatory standards such as PCI, DSS, and HIPAA is the one I know more about. It's more for health organizations. Recommend or require network segmentation as a security best practice. Implementing network segmentation can help organizations achieve compliance with these standards. It's just compartmentalization, guys, essentially, and you're keeping things away from other people. So if there's a breach, you won't have an issue. So, like for example, like I mentioned, marketing. If someone in marketing messes up, it won't affect someone in HR or financial accounting, because you don't want that would be more damaging than someone in marketing. I guarantee if someone in HR got compromised, oh good God, that's going to get messy fast. So, or in accounting, same thing. It's pretty detrimental. Performance and scalability. Segregating network traffic improves network performance by reducing congestion and improves bandwidth allocation. It also allows for easier scalability and network management, as changes or updates can be applied to specific segments without impacting the entire network. Pretty cool. So, examples of segmentation. Imagine you have a big office building with different departments like finance, marketing, and IT in an open space layout. Everyone can freely move around and interact. This is similar to a network, without segmentation, where all devices can communicate with each other without restriction. Now let's go in here and separate this stuff. Wish I had a picture. It'd be kind of cool. Separate floors as segments. In network terms, each floor is a segment. Finance, marketing, IT team on different floors represent different segments. So different layers, like a burrito. I'm sorry, I like burritos. Employees on one floor can communicate freely with their department segment, but accessing another department requires passing through control points. Makes sense. That's where a key card will come into play. Access control. Imagine turnstiles at the entrance of each department. If you don't know what a turnstile is, let me pull it up. It's that rotating door, if I remember. Oh no, it's not the rotating door. It's you'll see once I pick up the turnstile. You'll be like, oh, that's what he's talking about. Just let me Google it because I just want to show you what it looks like. I know some of you don't even know what turnstile is. I need a good picture of a turnstile. That's not the one I want. Bingo. This is what a turn. That's what a turnstile looks like. When you go through and you push the bar and it lets you through. Where you scan a badge or put in money, like you're going on a subway or something, or a bus station or an airport. Sometimes we'll have these in place. You would scan your boarding pass or what have you. That's what a turnstile is. Just so you know. So you don't get lost, so you get an idea what turnstile is now. Right? So only employees with right access cards, can pass through one of the department floors, beep, beep the card, put in money or what have you, your boarding pass for going on an airplane, depending on where you're going. Similarly, network segmentation uses firewalls and access control to restrict communication between different segments. Pretty cool. Enhanced security. Sorry, I had an itch. If an unauthorized person gains access to one floor, like let's say, a janitor would kind of have access to everything because they need to clean, but not like certain closets or certain things like IDFs or a storage area, like in a warehouse, they don't need to get to a CTIS warehouse, things like that. They are still restricted from freely moving throughout the entire building. Similarly, if a device in one network segment is compromised, the impact is limited to that segment. Like, if someone in marketing did something by accident, they mean to, now only marketing is compromised, enhancing overall network security. Isolation for better performance. Each floor segment has its resources like printers and servers. They're all separate from the other floors. This reduces congestion because local devices access local resources, enhancing network performance. Pretty straightforward. Let me get back to my control panel for the slideshow here. Almost done, guys. So let's talk about software-defined network. We're almost done, guys. 3 slides. One's a recap, so 2. Software-defined networking. SDN is a network architecture approach that enables the network to be intelligently and centrally controlled or programmed, in parentheses or in hyphens, using software applications. This helps operators manage the entire network consistently and holistically, so religiously. So pretty easy for them, regardless of their underlying network technology. SDN enables the programming of network behavior in a central controlled manner through software applications using an open API. So what are APIs? Let's find out, because I forgot. And we use APIs at work sometimes. We use this window. I'll Google it real quick. I think it's application packet, to be honest. Application programming interface. All right, so I was close. So I know we mentioned APIs for other stuff we do in SSCM, and Ben, if you're watching this part, I will answer that email for you like over Thanksgiving. I just have to think of a pretty good response because I'm asking my guys about it, so we can all be on the same page and give you some pretty good info. Share the wealth, right? Knowledge is power, guys. Keep that in mind. And side note, back in like 80s and early 90s, there was a show called Reading Rainbow, and it's about reading. Reading is power. That's where I'm kind of getting that from. If you're curious, Google it for the younger crowd in here that would not know what I'm talking about. I'm not trying to date myself. It's just So you guys have some context of what I'm talking about. Is what I'm referring to. So anyway, back into this stuff. By opening up traditionally closed network platforms and implementing a common SDN control layer, operators can manage the entire network and its devices consistently, regardless of the complexity of the underlying network technology. So here's what it looks like. There's a picture. So let's compare it to a traditional network. A traditional network and a traditional network. Let's say it 3 times. It's like something Beetlejuice. If you want to change the way data flows through the network or implement a new network policy, you will need to configure each individual network device, switches, routers manually. So you would need to change all that. You would go in there through PuTTY or SSH and configure all that. It can be time consuming. In SDN enabled network, the control plane is separated and moved to a centralized SDN controller, which is this guy here. You can see there. Let's say you want to prioritize video streaming traffic over email traffic. I mean, who wouldn't? Who do want to watch stuff at work, right? Like on YouTube and Netflix and stuff. Instead of configuring each switch individually, you can programmatically, which means you can just tell the controller to find this policy, and then the SD controller will push it out, and then you're done. So it's just one touch and go essentially, versus touch every device. The SDN controller communicates with the switch using OpenFlow or a similar protocol, instructing them on how to handle the traffic. So OpenFlow will be another 5-point exercise. You guys can just look up what OpenFlow is, what it does, tell me your own words, and send it to me for 5 points via PM on Canvas or email, and it's due before Unit 4 is published on Sunday morning at 10 a.m. when the videos go live. Is when I consider the unit published. I mean, I put it out Saturday night, so it's there, so you guys see it the next day, but that doesn't count to me because it's not Sunday. So once the videos go live at 10 a.m. for the lecture, and the labs go live usually at 10:30 or 11, your cutoff time is 10 a.m. because that's for lecture. So this is 5 more points. So that's 10 points extra credit so far. As a result, the switch, and side note, before I go back into this, if you're wondering how I use extra credit when you guys earn it, so let's say in an exam, you get a 60 out of 100, hypothetically. My exams are not worth 100, but I'm giving you an example. And you're like, man, where did extra credit apply? I will throw it into there to rate your grade up. That's how I use extra credit. I don't use it at the end. I use it during the whole class. I mean, I'll ask you probably, or if I see you haven't used it and I know you have a bank of like 20 points, like, hey, you want to put this on your final? So 20 points towards the final, or 20 points on a bad exam or a bad lab or whatever. That's how I use it. It's like a bank of just points you can put anywhere, or I will put anywhere for you depending on the situation. So that's how my extra credit works. If you want me to define it more, I might put it in writing later. But anyways, the SD controller communicates with the switch using OpenFlow. I just talked about that. So as a result, the switch dynamically adjusts the behavior based on the policies defined in the SDN controller. Right. So it just tells the switch, hey, let this go through and let this be priority. Cool. I'll do it. Whatever you say, man, you're in charge. Because if it's a physical switch, it's kind of a dumb switch, remember? If it's a virtual switch, I don't think that is. That would be a physical switch. So what are some key benefits? These are the 4 key benefits for it. I'm not going to get to disadvantages because, to be honest with you guys, I didn't find many. It wasn't really worth mentioning. So again, I mean, one disadvantage you can have and know somebody knows how to work it, because it's kind of weird, but it's doable. If you learn about it, it's not hard. No, we're not going to implement one. It gets too hairy. I don't want to break your guys' home network or public network or Starbucks network or whatever network you're on. I don't want you to break it, because then I'm held liable and I can't exactly go up to Merced, drive up 6 hours to fix it, and I'm not going to get paid for it. So yeah, no. So benefit here, network programmability. SDN enables network behavior to be controlled by the software that resides beyond the network device that provides physical connectivity. As a result, network operators can tailor the behavior of their network to support new services and even individual customers. That by decoupling the hardware from the software, operators can introduce, innovate, differentiate new services rapidly. And that's pretty straightforward. Free from constraints of closed and proprietary platforms. So it's more OpenFlow and what you want to do. That's what's called OpenFlow. Logically centralized intelligence and control. SDN is built on logically centralized network topologies, which enable intelligent control and management of network resources. Traditional network control methods are distributed. Makes sense. Devices function autonomously with limited awareness of the state of the network, with the kind of centralized control an SDN-based network provides. Bandwidth management, restore security, and policies can be highly intelligent and optimize organizations getting a holistic view of their network. Pretty straightforward stuff, guys. Abstraction of the network. Services and applications running on SDN technologies are abstract from the underlying technologies and hardware that provide physical connectivity from network control. Applications will interact with the network through APIs instead of managing interfaces tightly coupled to the hardware. Like you won't have to PuTTY and remote it, and then you just do it all from there essentially. So it's pretty straightforward. It's simpler. Openness. SDN architecture ushers in the new era of openness, enabling multiple vendor interoperability, as well as fostering a vendor neutral ecosystem. So you don't have to rely on Cisco for everything, or Brocade, or whomever. You can just pick, you can mix and match and make a mishmash of things with SDN. Openness comes from the SDN approach itself. The Open API support a wide range of applications, including cloud, orchestration, OSS, BSS, software as a service, SaaS, and business central network applications. I put apps, it's fine. In addition, intelligent software can control hardware from multiple vendors with open programming interfaces like OpenFlow, which I mentioned again. Finally, from within the SDN, intelligent network services, applications can run with a common software environment. So it's all one umbrella, one roof, either with different vendors mixed and matched. So guys, that is it. That's the end of Unit 3. I hope you're enjoying your Thanksgiving break and you watched this before Thanksgiving or during your Thanksgiving, and I'm in the background. I just hope you guys are enjoying it. So that's what I covered in this: virtual switches and routers, VLANs and trunking, network isolation and segmentation, and software-defined network. So there will be no labs, just an assignment, which is already posted. So have at it, guys. And I will catch you in Unit 4. I hope you had a good one. Take care, guys.